this video we're going to discuss some stuff about data types. Okay, so in Python basically everything has a type, so let's just define x to be 1, 2, 3, so then we can have a look at type x, and it says int, so the type of x is an integer. We could actually just have done type 1, 2, 3 if we wanted. That also gives us an integer. What about 123.4? Let's say 123.0 even. Okay, 123.0. I mean that's it's kind of more or less the same number, but it's kind of represented slightly differently as a floating point number that just happens to be an integer rather than sort of really being an integer. So in that case we get float. We can also have complex numbers, so let's look at, say, 1 plus 7j. J is the Python notation for square root minus 1, so that's a complex number, and we get the answer that it's complex. So that's different types of numbers, but you can also, the value true is kind of more or less the same thing as 1, but again, represented slightly differently. So if we do type of true, that's bool for a Boolean value. Boolean values are either true or false. And so we could do we do an inequality like this: 1, 1, 1 bigger than 2, 2, 2. Well, that's false. And that's just kind of another value that Python deals with. So we can ask for the type of this value. So the 1, 1, 1 bigger than 2, 2, 2 is the value of that expression is that it's false, and the full type of false is bool. So the type of that is bool. Also do things like lists. So we can do 1, 2, 3 type. That's a list. It's worth noting that there's lists and there's tuples, which are kind of slightly different. Okay, so the lists or tuples, there's lists and there's sets, which are all slightly different. We do this with round brackets instead of square brackets. Then that's a tuple, which is not quite exactly the same thing as a list. We'll see some technical distinctions between tuples and lists in a minute. But for the moment, we'll just notice that they're not exactly the same. And then we can also do it with curly brackets. So curly bracket 1, 2, 3, that's a set. So we need to ask for the type of that. It tells us set. Okay. So part of the difference between lists and sets, let's lists are ordered, right? So this list A is 1, 2, 3, B is 3, 2, 1, and they've got the same elements but in the opposite order. So they don't count as they count as different lists. And so if we do A double equal B, then that returns false. This is a Boolean expression whose value is false. If we do it with curly brackets instead, you do curly brackets just for A, then then A is a set and B is a list, so they're not the same. We do it with curly brackets in both cases. Well, we have curly brackets set notation. The set 1, 2, 3 is just the same as the set 3, 2, 1. So that's going to give us true. And notice you're also, in defining a set, you're allowed to mention elements more than once if you want to. And the set 3, 3, 2, 2, 1, 1 is just the same thing as the set 1, 2, 3. You've got the same elements, even though you happen to have mentioned some of them twice. So in that case, you get equality. Another thing you can do with Python is you can have dictionaries. So let's think about those. So here's an example of a dictionary. Let's call this. Okay, so we've defined a dictionary like this. So they've got two entries. So maybe write them on separate lines so we can see what's going on a little bit more maybe. Okay, so you write a dictionary like this with curly brackets, just like a set, but inside the curly brackets you've got some things with a colon. So if we do it like this, then we can kind of look stuff up in the dictionary. So you look up one, so you look for, these are called keys and these are called values, so you look to see if one is a key, and if so, produces the corresponding value. If we say 2, it gives us D. If we try 3, and we get a key error. Okay, so it's key error 3, that means that 3 is not a key in this dictionary because we didn't get that far. Maybe let's add it. So now we've got 3, but of course if we go to 4, that one's not going to work. Okay, so that's an example of a dictionary, which is useful for various purposes. I mean, here you can imagine something like this just for looking stuff up. It could be like translations or any other kind of thing where you've got keys and values. Another kind of thing that we can use a dict for is to sort of group kind of corresponding things together. So we could, for example, do we want to assemble various different kinds of information about the water python. So, for example, the scientific name, the genus is Liasis. Species name, Fuscus, right? So here we've got several different pieces of information about this particular kind of snake, and kind of standard that we want to collect all these different pieces of information in one sort of Python object, and so we use a dict for that. Okay, and then we can refer to it with square brackets like this. So we want to know the genus. It tells us genus is Liasis. Another thing we can do is functions. Functions are also kind of just normal objects in Python that you can use like other kinds of things. So we've got a squaring function like so. We can ask, ask Python what's the type of f? Well, f is a function, so that's another of the basic types that we use. There's many more types, all sorts of types referring to dates and times, referring to files, referring to URLs and web pages, all sorts of things. There's kind of specialist types for. So for values that you produce by hand yourself, they'll probably be covered by these kinds of things we've just mentioned. Lists or tuples or numbers or strings or functions or slight variations on those, but you should be aware there's many other data types which the web will tell you about if you need. That will be enough for the initial survey of data types.